Okay guys, so today we're going to be talking about, in this video, representing exponential growth. So they're going to give you a scenario, like a real life situation of something happening in the real world, and we have to represent the exponential growth as a function or a formula. So for that, we need to figure out what is the pattern, what's going on in the exponential function, or how can we write that as an exponential function based on the pattern that we have. By now, hopefully you guys have seen or read the story of the king's chessboard, which basically has to do with a king getting screwed over by a wise old man out of his rice. And if you don't know what I'm talking about, it's a really good story. You should read it. It's called The King's Chessboard. But anyways, it has to do with exponential function. It's talking about exponential growth and how do we represent exponential growth as a function. So let me give you guys a real life situation. So a colony of ants starts with 5 ants. The next week, there were 15 ants. The week after, there were 45 ants. Model this relationship with an exponential function. So when you're modeling this, I recommend for you guys to draw a table. That way you can see vividly what is going on in this example. All right, so term N, what are we talking about here? So a colony of ants, so ants, starts with 5 ants. And then the next week, there were 15 ants, and the week after, there were 45 ants. So the amount here, we're talking about ants, right? And then the term N, which is what the time is, the time frame, we're talking about weeks. So I'm going to just go ahead and say week number 1, week number 2, week number 3, week number 4, week number 5. How many ants do we have corresponding to that number of week? Week number 1, we started off with 5 ants. So I'm going to go ahead and write the number 5. Week number 2, they say that we have 15 ants in total. Week number 3, they tell us that we have 45 ants. Can you guys figure out the pattern of what's going on here? If you have not figured out the pattern, this actually is multiplying by 3, right? 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. And then 135 times 3, let's see, is 200. Wait, did I do that wrong? 15, 10. Yes, I sure did. So 405. Okay. So anyways, hopefully with this stuff, you probably have a calculator and it'll be easier to fill out the table, which I don't at the moment, but anyways. So we have 5, 15, 45, 135, 405. So we're multiplying by 3 each time, if you remember. On the factorization column, we're basically factoring or breaking it apart into what times what gives you the number on the left side. So my recommendation is always, 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 the initial amount of whatever it is that you're talking about, that's going to be the same all the way down the factorization. So we started off with 5 ants. I'm going to write 5, 5, 5, 5, 5. All right, so 5, 5, 5, 5, 5, because that's the initial amount of ants that we have. That being said, 5 times what number would give you the number on the left? So 5 times 1 would give me 5, right? So we're good on that. Now, move on down the list. Let's try to see if we can factor the other ones. 5 times what number would give you the number on the left? Well, 5 times 3 would give you 15. So we're good on that. 5 times what number would give you the number on the left? 5 times 9 is 45. So I can put a 9 there. But just so I can figure out the pattern here, I'm going to rewrite that 9. Instead of 9, I'm going to write 3 times 3. And you'll see why I'm doing this in a little bit. Do it again. 5 times what number would give you 135? So that would be 5 times 27 is actually 135. And if you didn't know that, you could also just divide this number by that number, and that would give you the answer of 27. Now, I could write 27, or I can just write it as 3 times 3 times 3, right? Because 3 times 3 is 9, and then 9 times 3 is 27. You'll see a pattern that it's following, right? The next one, how many 3s do you guys think we're going to have? So instead of 3 3s, we're going to have 3 times 3 times 3 times 3. So there actually is a pattern for an exponential function. Exponential functions are functions or patterns in which you're multiplying or dividing the same thing over and over again. In this case, that number that we're multiplying is we're multiplying by 3. So there is going to be a function related to this. So let's write this as a power. So again, 5 goes all the way down the list for not only the factorization, but also the exponents. So I'm just going to write the 5 all the way down. 5, 5, 5, 5, 5. And then we just have to figure out what goes here. So parentheses, how many 3's do we have? So I can write this as a power. So in this case, I have 1, 2, 3, 4, 3. So I'm going to write 3 to the power of 4. So I'm going to write it as 3 to the 4. Okay. Next one up, we have 3 3's. So 3 times 3 times 3, that would be 3 to the power of 3. If I go up the list, this will be 3 to the power of 2, or 3 squared. And then this will be just 3, or 3 to the power of 1. And then lastly, 1, that's actually 3 to the power of 0, believe it or not. It's one of the rules of exponents. So 4, 3, 2, 1, 0. Okay, I'm almost done. I want to write it as a function. So how do I write this as a function? So for that, we have to relate the term n. So these numbers right here with the power, so I can relate this function in terms of a power of n. So if you look at the exponents and you look at the n, so when week number 1, we have the exponent of 0. Week number 2, we have the exponent of 1. Week number 3, we have the exponent of 2. Week number 4, we have the exponent of 3. Week number 5, we have the exponent of 4. So 5, 4, 4, 3, 3, 2, 2, 1, 1, 0. If you look at it, we're actually subtracting 1 from n, right? So this whole column, if we take that and subtract 1, we get the power. If we take this and subtract 1, we get the power. We take that, subtract 1, get the power. We take this, subtract 1, get the power. So basically the final function would be this. It's 5 all the way down. So my function would be 5. That never changed, right? So that's my initial amount of n's. The number that we're multiplying by would be under the power, so that's 3. So that goes under the power. And then all we have to do is relate the power in this case. The power is the number of n, so whatever n number I have, subtract 1. So I'm going to write it as n minus 1. So my function for this particular situation would be this. 5 parentheses 3 to the power of n minus 1. Okay? We'll do one more really quick for comfort, and then you guys should be good to go with this. So the next one says, a small town's population starts with 600 people. The next year, due to job availability, the population grew to 2,400 people. The following year, the population became 9,600 people. Model this relationship with an exponential function. So basically, we have to write this as an exponent, kind of like the last example that we had. So in this case, we're talking about years, right? So term years, so this will be years. And then the amounts, we're talking about people. So I'm going to write people right in here. So year 1, year 2, year 3, year 4, year 5. And then we have to figure out how many people we have corresponding to that year. So initially in year number 1, we start with 600 people. Year number 2, the population grew to 2,400. So 2,400. Year number 3, we have 9,600. Year number 4, so first of all, what is the pattern that it's following here? How much are we multiplying? It looks like we're multiplying by 4, right? 6 times 4 is 24. 24 times 4 is 96. 96 times 4. Let me figure it out real quick. So 38 and 2 zeros. So 38,400. And then let's do it again. Multiply that by 4. Okay, so that is 153,600. Anyways, not that that's going to matter too much because we're going to be able to find a pattern in a little bit relating these numbers. So starting at 600, and every single time we're multiplying the number of people by 4 year after year, from year 1 to year 5. So factorization, I explained this in the last example that I did. So that initial amount of people that we had in this case is going to be the same number all the way down the list. So 600, 600, 600, 600, all the way down. So what we're doing is we're breaking apart or factoring of what number times what number would give you the number on the left-hand side that gives us the number of people. So if we do the first one, that one's easy, right? So 600 times what will give you 600, that would be a 1. 600 times what will give you 2400, that would be a 4. 600 times what will give you 9600, believe it or not, that is 16. But instead of writing 16, I am going to write it as 4 times 4. 600 times what will give you 38,400. That is going to be 64, but I'm going to write it as 4 times 4 times 4. And then the last one, what number times 600 times what will give you 153,600? That's going to be 128. 600 times 128 gives me that. But instead of 128, I'm going to write it as 4 times 4 times 4 times 4. There is a pattern that it's following here. So make sure you understand the pattern and where it comes from. Okay, all we have to do now is write it as an exponent. 600 is the same number all the way down. So 600 is the number that we started off with, the number of people. So that does not change. That remains the same all the way down so we can find the formula. All we have to do is relate the numbers that are multiplied inside of the parentheses as a power. So the bottom one, if I start from the bottom one, I have 4 to the power of 1, 2, 3, 4. So I'm going to write a 4. Next one is 4 to the power of 3. Next one is 4 to the power of 2. The one up is 4 to the power of 1. And the last one is 4 to the power of 0. Anything to the power of 0 gives you the number 1. So 4 to the power of 0 would give you 1. All right, finally, let's relate the powers with the years. So same as the last one, year 1 we have the power of 0. Year 2 we have the power of 1. Year 3 we have the power of 2. Year 4 we have the power of 3. Year 5 we have the power of 4. So year n, we have the power of n, subtract 1. So the final formula would be equal to 600 multiplied by 4 to the power of n minus 1. So you take the number of the year and you subtract 1. Okay, so this will be your final function. All right, I hope this video was helpful for you guys to model functions, especially exponential functions. Let me know if you guys have any questions. See you on the next one.